All right, good morning or good afternoon, I guess, depending on when you're watching this to everybody. Thanks again for joining us. Today, we're going to be talking a little bit about our Biosynthetic Technologies products in some finished formulations and some of the results we saw with that. I'd highly encourage, if this is your first time watching any of our presentations, to maybe go back. We have a kind of an introductory presentation around our technology, which gives a little more background and detail. But just overall, once again, I'm Matt Creek, Chief Operating Officer of Biosynthetic Technologies, and I'm joined today by our CEO, Mark Miller.
Good. Hello, everybody. Thank you for joining us today.
And so we're going to walk you through a little bit about some of the data we've collected on some prototype finished formulations that we've put together over the last few months here.
But before Matt delves in, I want to say that our objective is our vision is to deliver innovative solutions for a sustainable future. We are a component manufacturer. We are a base fluid manufacturer. It's not our intention to make finished products, but we were putting together some of these, as Matt calls them, prototype formulations, just to support you and the formulators as to how to make finished products utilizing our estolides.
Yeah, exactly. This being a new technology, we want to help our customers kind of get a leg up understanding how it might interact with other components in their systems and behave to minimize the time from kind of research and development to entry of new products. So, yeah, just recapping, Mark, thanks for leading that off. We are Biosynthetic Technologies, where we're about delivering innovations for a sustainable future. And said, hopefully in our last presentation, we convinced you of that. Just real quickly again, we're a company that's been around for about 10 years out of technology called estolides from the U.S. Department of Agriculture. Our goal is to deliver innovative solutions for a sustainable future, but our mission is really to be the premier synthetic base fluid supplier across a variety of specialty markets, lubricants being one of our early focuses. We are a standalone entity. We're supported by investors that are near adjacent in some of the businesses we're working with. We have employee engagement and ownership, and like I said, we're really focused on long-term bio-based issues and solutions to those. So.
We have a long background in bio-based lubricants and bio-based finished products, and over the time that they've been utilized, we've noticed a wide range of weaknesses that happened in the real world applications, and we believe that our estolide technologies have addressed most, if not all, of these weaknesses and are much more applicable to end products.
Yeah, exactly. And so here, once again, this is the structure of the estolide. It uses that secondary ester bond to create kind of polymers with fatty acids that can be varied in viscosity and a number of other factors. As Mark talked about, our goal was to address some of the fundamental issues of some of the bio-based solutions out there for lubricant base stocks. In this case, the things we focused on is hydrolytic stability of the molecule, and that's done by choice of the beta group and the inherent structure of that secondary ester estolide bond, good oxidative stability by using fully saturated esters, and really good demulsibility, meaning it separates with water. And once again, that's really about the alpha group we're putting on our molecules. So we feel that estolides with this technology, it really addressed kind of those three critical issues in the environmentally acceptable lubricant kind of bio-based platforms. So once again, here is the three BT products that we've commercially produced and are launching with. Viscosities from 4 to 75 or ISO 22 to an ISO 680. Relatively high bio content, 68% for the lowest viscosity, 94% for the highest. Here's again the summary of those base oil properties. So pointing out good viscosity index, acceptable pour point, really good flash point, low starting tan, low NOAC, so good volatility for various applications, and these are quite shear stable.
So what we wanted to do was to provide the industry with a low viscosity, a medium viscosity, and a high viscosity product so that you can formulate and blend any combinations of those to reach any viscosity grade you're looking for.
Yeah, the good solvency of these base oils means they blend well with each other as well with other products. So you can use a lot of combinations to create really the viscosity of target. And was also interesting is we are very flexible and tailorable on this chemistry. So for certain applications too, there's a specific on demand. Quickly, just refreshing kind of what the current regulatory status and certifications of our products. Our products are registered in the TSCA with US and Canada. Our BT4 is kind of going through its final phases of approval right now. We can do smaller and research level quantities. We're fully approved in REACH. We've done some work in some other areas, but those are the kind of the two focused target markets for us initially. Based on the environmental performance of our products, they are on the LUSC list, which means they can be used for eco-label formulations. And because of the high bio content, they meet BioPreferred status for a number of applications, including a passenger car motor oil, which we'll talk about a little later in this presentation. We have both INS and NSF HX1 certification for all three products, so they can be used in food contact applications. And the goal here is, once again, is just to give our customers a wide range of capabilities when using these products in finished formulations. So. And then finally, want to talk a little bit again about how we believe in circular sustainability here at BT. Our goal is to, obviously, these sustainable solutions. And the way we're doing this with our estolides is using castor as a feed source. We like it because castor is sustainable from an economic standpoint, from a socio-economic standpoint. It's on farmland. It doesn't really compete with food crops. There's no GMO used in the production of castor. And it provides a pathway for farmers in India to really kind of be entrepreneurs and rise in their socioeconomic status. We also like that in India, the manufacturing and the growing is really integrated in kind of one geographic region, minimizing transport and production of CO2 through transport, say, all around the world versus just a small geographic region. The plant that we're manufacturing these products at use wind energy for electricity, and it's boilers that drive the steam for our reactions are driven by the spent cake from the seed crushing process. So it's a very integrated, very sustainable layout. We've done a full life cycle assessment, which we're happy to provide to anyone. But the general theme is, for every metric ton of estolide that we're producing, approximately -9 tons of carbon is absorbed. And that's primarily done through the castor plant itself being a carbon sink as an agricultural product. So once again, if you're interested in this in detail, please see our earlier talks, or we're happy to share our life cycle assessment with you. Okay, now we're moving into some of the prototype formulations that we've developed with our estolide products. Up first is a couple different gear oil formulations. The first thing that we did is we started with a ad pack using our BT75 product. This is our high viscosity. So this would basically be an ISO 680 grade gear oil. And what we did is we tried essentially an eco-based, the eco-labels compliant gear oil, 4-point depressant, and ad pack. And we varied that ad pack at 4% and 2%, and then looked at things like weld load, wear index, and wear properties. And what you can see here is that at 4%, we have a weld load of 500 kilograms, and at 2%, we have 400. And then the product all by itself has a weld load of 160. And then the data in between X1 through X7 is competitor data that we took from basically published competitor data sheets. And a lot of these gear oils are not bio-based gear oils. These are actually crude-based or high-performance synthetic-based. And so what it shows is the BT products actually have very good load capability performance. They interact very well with this ad pack, and we see kind of best in class. So even a relatively small treat like 2%, you can have best in class weld load capabilities using the BT75. So once again, we like this also because the vast majority of the component was the BT product itself. So it kind of shows the characteristics of how these behave with really high loadings of estolides. We've done a little more comprehensive work on a different gear oil. In this case, we used, once again, a eco-label compliant additive package, about a 2.9% treat rate. And then we made a combination of BT75 and BT20 to create an ISO 220 gear oil and put it through kind of its paces. And once again, this would be kind of a standard grade gear oil you would see in the market. That way we can kind of compare ourselves to some of the other commercially available products to see how it performs. Initial data showed that, we did blend this to an ISO 220, had a very good VI of close to 180, very good flash point like we've seen before, well above 250 here, 272. Another theme you see with the estolides is, and we talked about this in our earlier talk, is that they have very good wear properties. And once again, very low wear scar, 0.321 here. And then the weld point for this product was 315, a little bit lower than the prior ad pack that we saw. We're also using BT22 here, which is a little bit thinner, so you'll have a little bit less of a weld load capability as you go down in viscosity. And then the other thing that we've run here is we ran some rust testing in both fresh and salt water. Sometimes you see this crop up as an issue in eco-label or bio-based products, and we passed those with no issue. We then took this data and we actually did a little bit additional testing and compared it with some commercial products that are on the market. And here's some data around kind of the chemicals that you see in it. You can see the viscosities, VIs. So in this case, we had the highest VI measured between the competition. We had our TAN was quite low, 0.68, which was good, similar to what you saw with some of the one commercial product, but much higher for another. Obviously, the higher that starting TAN, the more susceptible to hydrolytic cleavage is going to be. Our pour point was acceptable. It needs to be better than -9, and we were -21, although it was not as good as kind of commercial A and commercial B at -42 and -30. Very good flash points, needs to be above 200, and you saw we're testing between 260 and 270 with this product. Here, rust performance, once again, what's interesting is one of the competitors did not pass the rust performance test as we measured it. And the other one, remember we talked about one of the things we wanted to do was provide very good demulsibility. We see demulsibility failures in a lot of bio-based products. Here, ours passed, separated in 15 minutes with a clean separation, 42 and 38. A lot of times what you see is these don't separate clearly. There's kind of emulsion layer between. That's what's listed, or they don't separate in time. In order to pass this test, you have to separate within 30 minutes. Commercial A product did separate in 15 minutes, although it did kind of have this emulsified layer in between. And a commercial B product actually did not pass demulsibility. So once again, we feel like the estolides here are providing good capability on that. The foam testing, we saw some issues with a commercial A product. Here with ours, we passed the volume increase, no problems. And oxidative stability was really best in class once again. So here at 1.49 versus a 1.67 or 1.97 for our competitors. And we talked about this last time. One of our goals was around, kind of best in class hydrolytic and oxidative stability. So what this shows, I think, is that we can be very competitive in a gear oil formulation that uses a high percentage of estolides compared to other bio-based products, and that we kind of pass all the key qualifications where some of our competitors using competitive products may be passing some, but also failing others. And so we really optimized around fixing some of those issues. Mark, any additional comments on the gear oils?
No, I think you've done a great job characterizing them. I think it's very simple depending on what additive package you utilize. We wanted to demonstrate the flexibility with a wide range of additive packages to make a fully formulated gear oil that meets all the specifications and is still sustainable and eco-friendly.
Excellent. So now we're going to be moving on to greases. We've done a prototype grease formulation, which we'll talk about here. What's interesting about greases is initially, bio-based greases were a little bit challenging because they had a hard time surviving kind of the cooking process. As you kind of cook a grease with a bio-based product, especially if it's an ester, you're heating it up to relatively warm temperatures, above 200 C. There's usually some water present from the soak process that goes into it. Water plus heat means significant hydrolytic damage usually, and a lot of times the bio-based products would fall apart before they could basically be cooked and finished as a grease. There's been technology developed to get around that solution, but what we view with the estolides is because they're hydrolytically stable, we can kind of go back to more traditional grease technology to be able to do that. And so we're exploring a lot of grease formulations right now and just have some kind of early data we can show around our first grease. In this case, we've made a lithium grease, and this is based on lithium 12-hydroxystearate as a thickening agent. Once again, we've chosen a grease formulation that uses a high percentage of the estolide product just to kind of show off its properties. So in this case, it's about 85% BT22. And then what would be kind of a relatively standard grease package for making this. In this case, the grease was cooked at 220 C. So once again, those high temperatures where hydrolytic cleavage could occur for other, like say, primary esters. And then we homogenized the 6,000 PSI for the grease. And so we were able to actually put this grease together, and the estolide did survive kind of the high temperature cooking process. We then went on to test this on a number of different kind of performance characteristics and compared it to some of the GCLB specs that are currently out there. So 4-ball wear, coefficient of friction looked very good for the grease. The work penetration came in at 276, which is well within the specification range between 220 and 340 for these products. By the way, we were focusing on an NLGI grade 2 grease kind of as the initial kind of prototype formulation. You can see evaporation, oil separation, work penetration. All these are acceptable numbers. The dropping point at 249 was very good, well above the 150 minimum required in those specs. Here you can see the 4-ball wear, about 0.42, and coefficient of friction of 0.072. See, that's actually been reduced from kind of the base oil that we saw measured above, and that's some of the additive technology you're seeing that was used in this formulation. Once again, the spec for that is 0.6 max, so we're well below that with our 0.42 wear scar on that. The low temperature viscosity -23. Once again, that's kind of apparent from the inherent properties of the BT. Oxidation induction time, we did 180 C, and we saw no exotherm out to, I think it was like 180 minutes actually, I apologize, I don't remember the exact length of that time, but there's no exotherm measured, which basically means, once again, this product is viewed as oxidatively stable. And 4-ball extreme pressure, once again, close to 315. Which is usually the characteristics of these BT22 and BT75 products. And once again, you've got to be above 200 for GCLB. So what this suggests is, with really very little work, this was essentially the first time out of the gate we tried to make a grease. We essentially have a very close to a GCLB compliant grease formulation with this lithium grease. Now, obviously, there's more work to do. We want to make some calcium sulfonate grease, some lithium complex greases. There's a lot of technology that we're working, hopefully, with some partners on this. But it just shows that we feel estolides may be a very interesting base oil for the formation of eco-label and bio-based sustainable greases. So, any other thoughts or comments on greases, Mark?
No, actually, I was just going to amplify what you said about the estolides being a great base oil. And you can formulate a wide range of greases depending on the additives and soaps you use to suit the application that you're looking for. So I think it's a great opportunity in the grease sector.
Yeah, I think we're really excited about exploring this one more, and we think it's a really good fit with our technology. One of the other product families that we've done some work around is hydraulic fluid samples formulation. So now we're kind of, what's interesting is we've worked on the really high viscosity grade gear oil regimen relatively well. We focused on kind of the mid-range with the BT22 and grease formulations, and now we're kind of moving on more to some of the lighter viscosity products. As you can see, we're kind of stepping down, and as you see, we'll end with PCMO, where we're kind of at the lowest viscosity of all of them. But for hydraulic fluids, we've done a number of prototype formulations. This one, what we wanted to do was see what happens with our estolides when we mix them with other types of base oils. We've always talked about having very good solvency, and we wanted to see that. And we also wanted to see what happened with the kind of overall properties of the finished fluid when you do these mixtures with other base oils. So in this case, our goal was to create an ISO 46 hydraulic fluid that would still be fully biodegradable. And so to do that, we used a PaO2 2-centistoke product, which is still biodegradable. And to get that ISO 46, it's about 68% BT22 and 31%-ish PaO2. Once again, use kind of a standard eco label compliant ad package to formulate this hydraulic fluid. And we kind of put it through its paces from a test standpoint. What's interesting here is we saw a significant improvement in pour point, and that's what's happening there is that, these PaO2s have very low pour points, and basically that is helping the overall formulation. So one way of improving pour point with our estolide products is to be able to blend with other base oils that have good pour points. Just as a side note, I think we talked about this last time, is most pour point depressant technology tends not to have much effect on estolides. We've tried quite a few. We're still looking for one that may work, but in general, pour point depressants don't have a significant effect. Where we see the best bang for the buck is blending with other base oils that have lower pour points. And then you see the result here to get into the minus 30s. So we did hit the KV40 of about 44, so kind of within grade for an ISO 46. Once again, a very, very good VI, low 180s here. Now, this is what's interesting here is you see the flash point is, on our previous products that were closer to like 270, there's been a significant reduction in flash point, and this is coming from the high volatility of the PaO2 product. So we did measure oxidative stability though, and we see very good oxidative stability, endpoint of about 800 minutes on the RVPOT test. Actually, the curve for the RVOBT is there on the left. You can see the endpoint and the induction endpoint as well. They're actually pretty close together. We've also ran a hydrolytic stability on this product, once again, just to make sure, even with blended, that you still see good performance. And what you see is a very small change in acid number and a very small tan for this product. So this is a very hydrolytically stable formulation, which can be important for hydraulic fluids. So kind of bottom line here is, yes, estolides blend well with other things, especially those that may not be as solvent, like PaO2s or highly refined group 3s. You can improve the pour point by co-blending, and you still get good oxidative and hydrolytic stability, which has been our big focus around that. So. The other thing we've done is we put another formulation together and have run through paces looking at elastomer compatibility on these products, because once again, we're a very high component portion of that. We wanted to see how we affect. We talked about elastomer compatibility when we did our prior talk. Here we ran kind of a couple of different ones than we showed in the previous presentation, HNBR, FKM2, and NBR1. And what you can see is based on the ISO 15380 limits, we were compatible for all three of these products. As I talked about before, in general, lower viscosity BT products like the 4 or high 4 tend to act like traditional esters, whereas the 22 and the 75 act a little bit more like PAO in that and how they affect the seals. But as you can see here, we were well within specification for all of these elastomers. So once again, our materials show good compatibility with elastomers, meaning they can be used for a wide array of applications.
And to amplify what Matt just said, the NBR1 that's used in the ISO 15380 test is usually a stumbling point for bio-based and high bio-containing products. And you can see from the data that we came into specification very, very readily.
All right. So we've covered kind of the full range here. Now we're moving into kind of using the lightest viscosity products. In this case, passenger car motor oil sample formula. And actually, I say that these are a little bit beyond sample formulation. We actually have made a full API or API certified GF5 motor oil. This was technology that came out of kind of the earlier 10 years using continuous process estolides derived from soybeans, so high oleic soybean technology. Sorry, Mark, did you have a comment?
No, I'm sorry. I'm fine.
No, okay. And so these formulations were put together using about 35% of that high oleic soybean containing product. Once again, we always say that we can be feedstock agnostic. We're using castor for one products. We have the ability to use oleic. In this case, the high oleic soybean oil was a great starter and produced a great product for us with that technology. And we also really like the technology that the high oleic soybean oils provide us. And so in this case, we made a 5W30 and a 5W20 API certified GF5 motor oil. And here you can see the approximate formulations, so about 3.5% VI. The estolide and co-base additive are about 40%, and so about 35% of that co-base is actually the estolide itself. And then we just use traditional group 3, 4, and 6 centistoke product. And we'll talk a little bit about the data here, but you can see in the bottom right is well, one of the exciting things we did with this project was we ran a field trial after passing all of our engine sequence testing, and this was done in a taxi cab fleet in Las Vegas. So kind of stop and go, super high desert temperatures, kind of worst conditions. We ran against a kind of a non-synthetic conventional motor oil versus our estolide. And remember, we talked about estolides having very good solvency, very good detergency, and you can see the difference between the left and the right is the estolide engine was very clean. So it takes that varnish off, whereas conventional, you don't have that same solvency. So interesting application. Here is, we did a full engine testing sequence to get that API GF5 certification. Here are the results of that testing. What's interesting is we actually passed this sequence test the first time through. Really highlighting, I think, a very solid formulation. So, and good technology being provided by the estolide. So once again, just amplifying what Mark said at the beginning, our goal has never been to be a finished formulation producer. In this case, our goal was to once again highlight the capability of estolides in really demanding applications like passenger car motor oil. And so we formulated one that we knew would pass. These are expensive tests, especially all these sequence tests. We wanted to get through them first time through. And so really formulated an engine oil, really all around performance so we could pass those. But once again, it highlights, especially the low volatility. I mean, NOAC and volatility is very important in passenger car motor oil. The estolide provides a significant advantage in that. And here you can see that in this low 6 centistoke product that we blend with, this comes out quite well.
Before you move on, Matt, one of the things we want to point out was that one of the targets besides first-time passes and all the sequence testing was to meet the U.S. Department of Agriculture's BioPreferred level. BioPreferred minimum content for engine oils is 25% minimum, so we targeted slightly above that. So this product not only meeting the ILSAC and API, but also meets the USDA BioPreferred. And while, again, we said before, it's not really our intention to sell finished motor oils, we had such a request and such demand from some of the fleets that we had launched a product and it's now available on Amazon. So go buy some.
And then just wanted to show, and talk about this a little bit earlier, but this shows a little bit better the pictures of that engine trial. This was a 150,000 mile or approximately 240,000 kilometer taxi cab trial, 10,000 mile drain intervals on the estolide technology. And obviously we took the engines apart at the end, and it's one of our favorite things to show off at trade shows and others. Drop by our booth and we're happy to show you our engine blocks. But really just, from a visual standpoint, clearly shows the difference between kind of a conventional and, a fully synthetic bio-based type product. So now, one issue that as a small company like us that we're running into is GF5 is expiring, so we'll lose our API certification here next year, and so we are working on a GF6 formulation. Once again, the idea for us is really highlighting what the estolide technology can do. We obviously were hoping to have partners in doing this, once again, because we don't want to sell finished formulation engine oil. But we are starting to do some initial work just to convince people it's really worth kind of betting again on our technology. In this case, we've gone from a 6 centistoke down to a 4 centistoke BT4 product. And the goal here is to get it from a 5W20 down to a 0W20. Which is one of the fastest growing PCMO market segments. And so in this time, though, we're trying to put together a more standardized formulation using an off-the-shelf ad pack technology, so that it'd be very similar to what anyone else is using. We tried to up the overall content this time of the estolide from 35 to 38%. And the other thing that we're exploring in this round is to make the product more sustainable, have a better carbon footprint, is the use of re-refined Group 3 products. And we're hoping to work with a number of manufacturers around that to make this a more sustainable, a more kind of compliant. And now it won't help with, say, like the BioPreferred program. The bio content is really driven by the BT4. But from a carbon footprint and life cycle assessment analysis, that re-refined provide a big impact to the overall kind of calculation and CO2 footprint of that oil. This is a phased approach. So we're kind of in that initial phase 1, phase 2 bench study blend studies, bench testing to get the viscometrics right. Been working with our additive supplier on that. But as I said, what we're really looking for here is hopefully a consortium that would want to work with us to get us through this GF6 sequence testing for the engines. We have some very early we have some very early results on this. We are able to actually blend these in specifications. They've passed the cold crank, MRV, viscosities. So from a bench testing perspective, we're feeling pretty confident that we've got the right formulation. And now we're working on what it would take to put a kind of an engine testing package together down the road here. So, but really the goal here was to, once again, highlight the estolide in a wide array of different kind of finished formulations, from really high viscosity gear oils down to very low viscosity passenger car motor oils, and everything in between. And hopefully what we've convinced you of is that the technology works in a wide array of applications and has solved some of the more traditional issues where you were unable to use these bio-based products because of poor oxidative or poor hydrolytic or poor emulsibility. So, like I said, hopefully we've convinced you that even in final formulation products, these work quite well. Mark, anything to kind of add as a final note on our finished formulation data?
No, I think you've done a great job covering that. We're really excited about the development work. We're looking forward to supporting all of your efforts to do formulations. We've got a lot of expertise with our estolides and hope to share that with you as you move forward. We appreciate your time and consideration, and I look forward to working together.
Thanks, Mark. And as Mark said, if you want to stay kind of up to date and how to get in contact with us, lots of different ways. We have a great LinkedIn page, keep things up to date on Twitter, have a nice redone website that also has a blog. We try to release white papers and articles in there. Working on a YouTube channel, lots of different ways to kind of stay involved with Biosynthetic Technologies, but highly encourage you to follow us on LinkedIn if you're not, and we keep things kind of exciting and fresh there, and especially the era of COVID-19, there's great ways to even keep in touch just through your computer. So I thank you for your time. We appreciate listening to these. If you have any questions, feel free to reach out to Mark or myself. And stay safe, stay healthy, and we look forward to talking with you soon.